Hello, my name is Garcia. I'm the Director of Solutions Engineering here at ANM, and we're going to talk a little bit today about Zero Trust Architecture, or ZTA. We'll go over a brief framework of what Zero Trust is and how we can apply Zero Trust concepts into our network designs. So Zero Trust was outlined in a NIST publication called 800-207. Now, for those of you that haven't read this publication, you can basically boil it down into three core tenets. Those things being never trust, always verify, only provide least privilege access, and then the third one is always assume breach. So let's take a look at these three concepts and try and apply them into traditional network design and see how we can improve, or how we could potentially improve, our security postures in our network. So the first one we'll look at is remote users. So typically, remote users use VPNs to connect back to our networks to access their applications. If there's an agent or a client that lives on this mobile device or this laptop, once their user authenticates, then it tunnels over the internet back to a firewall. And the firewall then has connectivity back to our data center. Our data center here. And that's where all of our applications. We have our app that lives here. The user authenticates, tunnels back in, and that firewall then has a policy that either permits or denies this entire VPN subnet to server subnets or application subnets inside the data center. Now, if we take this model and look at our core tenets of Zero Trust, we can see things fall down a little bit. First one, we've authenticated them one time, then we allow them in. We're not continuously validating that they are who they say they are. Secondly, least privilege. By default, what most network administrators do is permit large subnet ranges back to other large subnet ranges. So we have a VPN subnet, we have several application subnets. This entire subnet does or does not have access to this other subnet over here. So that does not meet least privilege requirements because there might be other devices or other applications in that subnet that this user may not need access to. And the second one, the final one is assuming breach. If something were to happen to this device or to this user and they were compromised, they have full network connectivity laterally between other devices that they're permitted to within the same subnet that this policy is allowing. So again, we're not adhering to best practices as they relate to Zero Trust in these traditional network design models for remote users. So how do we improve our security using these three principles? So what we like to do is look at something called ZTA. So ZTA stands for Zero Trust Network Access. And what it essentially is a user authenticates via some sort of ZTNA service that sits in the cloud that connects back to your Active Directory, some sort of identity source. Once they're authenticated, we can profile their device and take a look and make sure that that device is permitted on the network, it's owned by the company, things like that. Once we've validated all that, then what we can do is create a per app tunnel directly from our end user device to the specific application that they need access to. So they've only been now given access to applications that they need to use their job. So as a very quick example, let's say this remote user is an HR, and this application down here is an HR app. This is the only application they need in order to do their job. Rather than giving them access to entire large subnet ranges within the data center, now we've created a tunnel that goes directly to this application, to the end user. So they only have access to that. And we can continuously challenge this user to make sure they are who they say they are. This device doesn't change, their identity doesn't change. From a privilege standpoint, they only have access to this one application to do their job. And then if something were to happen, if they were to be breached, there is no lateral movement between these different applications. They only have access to this one. Now, let's take a look at our campus. I'll draw our campus network here. Now, from a campus standpoint, not only do we have end users, obviously, we also have things. So cameras, we have phones, badge readers, IoT devices. So by default, on traditional campus networks, a user would plug their laptop into a switch port or hop on the wireless, and by default, they'll just have access to everything within that same network, and potentially even access to things inside the data center directly. So what can we do to improve that security? One thing that we can do is use this exact same ZTA solution, not only for remote users, but also on-prem users as well. There's no reason why we can't treat on-prem users the same as we treat remote users. That way we can treat our campus just like any other site, whether it's the office, or remote office at home, Starbucks, the airport. The security remains the same no matter where they go. So we get the same benefits here from using ZTNA, both remote and on campus, where we can do things like create a direct tunnel from our end user directly to the applications that they need access to and nothing else. Now, this model works great for users because we can apply, or we can install an agent on their devices. But what about IoT, right? You can't put an agent on an IoT device. You can't put an agent on a camera or a badge reader or a phone. So what do we do for those? Well, we go back to a traditional NAC solution. So what our NAC solutions could do is apply policy down to the switch port layer here and here. So either on the wireless or on the physical switch port that these devices are connected to, we can use NAC to push a policy down to these switch ports and then block traffic between our IoT devices and even between our users. So this is one option. We could also continue to use NAC for users as well. We don't have to use ZTNA. We could also use our NAC to do 802.1x and then do the same thing. Block at the switch port layer, block on the wireless, and only permit specific types of traffic once our user's authenticated. So there's a couple different things that we could do on the campus in order to adhere to these three principles. And finally, on the data center. So from a data center perspective, the way that we typically do security in the data center is we'll break up our applications into different VLANs or subnets. So let's say there's VLAN 1, VLAN 2. We want to secure traffic between these VLANs. Generally, what we'll do is trunk those up to our firewall. We terminate our layer 3. And then at our firewall, we can enforce policy between these different VLANs. Now, this is great. The challenge is that we have to send all that traffic to the firewall and the back end again. And this doesn't solve for things that are on the same VLAN. So if we look at our principles again, least privilege access, these guys are going to have access laterally between each other without any filtering from the firewall, because if these are on the same layer 2 segment, that traffic isn't seen by the firewall at all. They just directly connect and are able to speak to each other. So if a breach does occur, then that breach could then move laterally from east to west. So what can we do to improve our security posture and adhere to these principles in the data center? Let's draw out another application out here. We have another app. Now, in order to adhere to these NIST principles for zero trust in the data center, what we can do is look at something called microsegmentation. Now, there's a few different ways to do microsegmentation in the data center. The first one being network. So leveraging the network to microsegment. So instead of using VLANs and subnets and trunking everything to the firewall, what we could do is apply a security policy directly on the physical switch port here that host is connected to. So very similarly to what we're doing with NAC and the campus. So we have a policy on the physical switch port layer of our application. That's one option. Another option is to do it via a virtual machine layer. So most applications in our data center are going to be virtualized. So there are options to to do microsegmentation at the VM level, and then enable things like firewall policies directly at the VM. So not only doing things like layer 3 security, layer 4 security, but also enabling things like IPS, IDS, content filtering on the virtual machine layer. And finally, you could go down to the operating system level and use an agent-based solution to do microseg. So what this does is it's an agent that gets installed on the operating system that sits on this host. And what those will typically do is orchestrate either the Windows firewall or Linux IP tables, either permit or deny traffic based on our policy. And so what we're effectively doing is taking what we did on the firewall, but pushing it further down, closer to the host, closer to the application, to microsegment things. So now that was a very brief, high-level overview of what Zero Trust architecture is and how we can leverage Zero Trust principles to make our network a little bit more secure. If you want to learn more, if you have any questions, send an email to info@anm.com or talk to your local account team. Thank you.